Hello friends, welcome in this presentation on PLCs. This is an introduction to programmable logic controllers, PLCs for short. I'm going to cover these outlines in this presentation. The origin of the PLC were started to get rid from the complex control systems which are costly, require large space, complex and time consuming troubleshooting, tedious rewiring, etc. A programmable logic controller is a unit of hardware and software which is used to control and automate an industrial process. They were initially designed to replace hardwired relay-based control. Nowadays, they can even perform PID control action. A relay, basically electromechanical relay, is a device that responds to a voltage change by activating a switch. When the input is energized with a voltage, a current will flow through the coil and cause it to become magnetized. Magnetic force will pull the contact close and thus close the circuit. When the input voltage is taken away, the magnetic will deactivate and the contact will open again. A PLC is a microprocessor based controller with multiple input and output. It uses a programmable memory to store instructions and carry out function to control machines and processes. The PLC perform a logic function of relays, timers, counters, and sequencer. So it have low cost, reliable, and reprogrammable. The first PLC was developed to help General Motors to eliminate the high cost associated with inflexible relay control system. In large applications where thousands of relay may exist, wiring and troubleshooting could be quite complicated. So the solution came out in the form of PLC. Therefore, the advantage of PLCs are less wiring between device and relay contact are done in the PLC program, easier and faster to make change, and system had to be reusable. Troubleshooting aids makes programming easier and reduce downtime. Reliable component make these likely to operate for years before failure. In this and next slide, we give a look on the PLC development year by year from concept to advanced development. Advanced development in the form of SCADA. So I'm not going to discuss about SCADA. So these are the popular brand name in PLC world. In next tutorials, I have to work on Mitsubishi PLCs. PLCs are as an universal controllers, so it has the wide application areas. They are implemented in a variety of control operations from large to small. It can be used for different applications via the program installed in its memory, provide the user with a simple means of changing, extending, and optimizing control processes. Small PLCs are capable of providing simple to advanced level of machine controls. Medium PLCs are capable to advanced level of machine control, and the large PLCs can control individual production process or entire plants, depending on the input number of the input and outputs and the memory capacity. So here are the three main aspects of the programmable logic controllers: input, output, and the control program. The input are connected to the sensor devices that inform the PLC about the external environment. The program uses a set of logical instructions that drives the output based on the input. The outputs are connected to the equipment needs to be controlled, such as a motor or alarm. In this diagram, X shows the input and Y shows the output. L1 and L2 are the power rail, and the PLC is programmed through programming port or USB port. So PLCs replace all the wiring and individual pieces of hardware like counter, timer, and relay. Before PLC were used, the wiring, configuring, and troubleshooting all these components would often get very complicated. With a PLC, all wiring is done in software, so programmer uh, have to update the program and then load it into the PLC memory. PLC has four major internal components: the CPU, which contains the microprocessor, register, control clock, and the various other processing units. The memory contains user's program, program data storage, and PLC operating system. And the input and output modules provide the interface between the system and the outside world. So there are many trade-offs when deciding which type of the input or output cards to use. So DC has some advantage over AC, as the DC voltages are usually lower and therefore safer. And DC inputs are very fast. AC input require a longer on time depending on the frequency of the AC input. DC voltage can connect it to large variety of the electrical systems. Uh, the advantage of the AC over DC: the AC signals are more immune to noise, uh, so they are suitable to long distance and noisy environment, uh, especially magnetic noisy environment. AC power is easier and less expensive to supply the equipment. AC signals are very common in many existing automation devices. Here the input signal conditioning circuit block diagram for the DC input module. The current limiting resistor are used to drop the input voltage to logic level, and the opto isolator provide isolation as it prevent from the voltage transient and the electrical noise. Buffer is used to prevent loading effect, and the filter and hysteresis circuit remove the noises. Here the input signal conditioning circuit block diagram for the AC input module. So here the rectifier, which is converts the AC input to the DC, and a resistor network drops the voltage to the logic level. And the function of the isolator, opto isolator, buffer filter, as I discussed earlier. Here the output signal conditioning circuit block diagram for the DC or AC output module. So TTL circuits for 5 volt. Okay. Some example input devices for a PLC or programmable logic controller are push button proximity switches, photoelectric sensors, temperature sensors, etc. Anything that can be measure the environment and then transmit a signal to the PLC's input. PLC outputs are the anything that would need to be controlled based on the input, like motor, indicator lights, fans, or heating element or alarm. The input and output on a PLC can be analog, discrete, or digital, depending on the specification of the PLC. The common input and the output voltage are 12 to 24 volts DC, 120 volts AC, and 5 volt for the TTL logic devices. The PLC CPU is protected by the opto isolators. Uh, this is a electrical isolation from its input and output. The opto isolator use a LED and the photo sensor to convey the voltage information. This way, if there is a large voltage spike, the PLC and its CPU will not be damaged. Here a figure that show two common type of PLCs, a single box type and modulator or rack type. Read out these slides for the feature of the box type PLCs, and the next slide for the modular type PLCs. So at this point you should realize how PLC can solve many problems in industry. PLCs are flexible and can be reapplied to the control other system quickly and easily. They are cost effective for controlling complex systems. They possess high computational abilities that allow more sophisticated control through the ladder logic. Troubleshooting aids make programming easier and reduce downtime. Reliable components make PLC likely to operate for the years before failure. So, in the next tutorials, I'm going to discuss ladder programming for Mitsubishi PLCs. So, thank you.